And they may well ask, why climb the highest mountain? Why 35 years ago, fly the Atlantic? Why choose this as our goal? Not because they are easy, but because they are hard.
So this link will be very useful to you. You might want to scan this QR code now. It will pop up again, but this will help you with the onboarding process later throughout the GBM. We'll give him like, we'll give him a minute. Never mind, you guys don't know. Discord and Rocketry to utilize our membership form as well as our team. Ignore him. Next slide, please. So as we have, this is our team. This is our team at the end of spring. This isn't everyone in our team. This is actually a relatively small portion of us, and as you can tell by this room, it'll only be an even smaller portion this year. So I do want to go over a little bit of the history of KXR. So this is our timeline. For those of you who don't know, KXR was actually a collaboration from AFAA and SES in the past. In 2019, in the past, we were AFAA and UCF Aluminium. SES UCF made in-cut cusses 1 and 2 as well as tempers. 2019 through 20, we were AFAA and SES. We were known as UCF HPR back then. We were the regrettably named Big Chungus. 2020 to 2021 is when our founders made KXR. Big Chungus continued to campus arrive. And from 2021 to 2022, KXR actually officially formed as an RSO. Big Chungus continued in IRAC. In FAR, we took first, second, and third place, which you can actually see over here in California. This was the time the HPR program started as well. This is when we started making certifications, and to this day, we've had over 200 certifications in L1 Rocketry. We got our first L3 this year, and our first dozen L2s the previous years before. 2022 to 2023, we made Pegasus, the strongest hybrid motor in UCF history. We also made Valkyrie, the first collegiate liquid biprop in all of Florida. This was an endeavor that we did in 1 year. People at UF have been doing it for over a decade, and people at UCF have been doing it for the past 4 years. We made Zeus, the first collegiate electric thruster in all of Florida. Less than a dozen schools in the nation have actually done this. We did it in the course of a year. We made Asclepius. This was KXR's first time NASA student launch and got the third place Rookie of the Year award. This was a team of people who were all new to rocketry and made place nationally. We also had TNTG and 1. These were 2 L-class solid motors, some of the strongest motors we've made. We also had our HPR program do over 150 plus L1 certs in 1 year. This year, KXR became the largest RSO. This year, we'll be going back to Spaceport America. We'll be doing FAR 10K with a liquid rocket. We'll be continuing our ion propulsion project with a Hall effect thruster. We'll be continuing the NASA Student Launch Initiative, solid development, making the first ACP grains that UCF has ever made. We'll continue the HPR program. We'll be test bedding and doing R&D inside the HPR program as well. We've also made a bunch of new partnerships. We've rekindled our relations with AFAA, IEEE, FPV Knights, Hack at UCF, and Night Hacks to become even better than we were before. For those of you who don't know, every club at UCF has an executive board. Rarely we get to actually mingle with the members. This is a great time for us to get to know you. So we're going to get started and introduce ourselves. I like to do it. So a little bit about myself. I'm a major in aerospace engineering with a minor in computer science. I'm graduating either, well, this is my second year in college. I'm graduating either fall 2024 or 2026, I don't know anymore. My experience was when I was a freshman, I joined KXR. I actually got recruited by, let's see, do me a favor, Dave, stand up real quick. That was one of our executive board members, one of our founders. He actually dragged me into definitely been a great mentor for me, and he'll be a manager this year, so you guys can learn a lot from him too. But he regrettably recruited me. And I actually became the MSL Payload manager my first year. A very unique opportunity. I got to lead a team of over 50 people, and that made me the leader I am today. In April, I became president, and Mr. Prez. In research, I worked in the high-pressure extended shock tube for advanced research, aka Hyperstar with Dr. Masu. And in the industry, I worked with the Florida Space Institute Exolith Lab, and I've also worked with Siemens Viable Engineering Solutions. Fun fact, I was blinded by an anthropology major last weekend. What about anthropology? Don't worry about it. How do you use?
Oh, okay. Hi, I'm Samantha Keen. I'm Vice President. I pick up all the tasks that they leave behind because it gets really stressful. You guys might have met me at orientation. I'm kind of like Kibler-in-Chief. I'm also an aerospace major, obviously. I didn't start out that way though. I came to KXR because I was like, do I actually want to be an industrial engineer? And the answer was no. I started out as a safety officer on the NASA Student Launch Project, and I've got a bit of my other experience up here. But my most recent stuff is in KXR as Vice President. I pick up a lot of different tasks, and I love each and every one of you, and I have so much passion and love for all of you, and I just want you all to succeed, and that's my job. I'm going to be starting as a CWET for all of you who might be interested or might be one. I'm excited for that. I'm from Chicago. I have a really fat dog, and I'm and I'm a vegetarian.
Hi, my name is Chris. I'm your secretary. I'm an aerospace major as well for the third time you've heard this. And I'm also doing material science as my minor. I have been in KXR since my first year when I joined NASA Student Launch in their aerostructures team between design and analysis and manufacturing. And I realized that this was the thing that I wanted to do for the next 4 years-ish of my college experience. So I also work at Pearl, which is the Propulsion and Energy Research Lab here, as an undergraduate researcher. And I used to tutor AP Calc, so if you come to me about math, I'll kind of know it a little bit. And I got my L1. I love Garfield, and I do gymnastics sometimes, and I have a wonderful boyfriend named Tristan who has 2 rats.
Hello, I'm Camila Martinez, and I'm your treasurer. Guess what my major is?
It's aero! Can we get some noise for all the aerospace majors that have decided to participate in this general board meeting tonight?
Alright, I've been taking IRS courses. My job is to make sure everything we're doing with money is legal. If not, I'm going to court. I might go to jail. So please, don't make me go to jail.
Hey guys, my name is Subhan Wade. I am your current Director of Aerostructures, and I'm in charge of anything that you do with the airframes of the rocket, all internals and external, structural components. So I'm, of course, an aerospace engineer, but I'm minoring in intelligent robotic systems and mathematics. I like doing some bouldering, hiking, among many other things, yada, yada, yada. I'm originally from the West Coast, so I'm a long way from home. I'm excited to be here to help all you guys learn aerostructures and to develop your composite skills. For experience, I started off just about 1.5 years ago as assistant aerostructure lead under Sophie Riccio. It was an amazing experience. It set my foundation for how I got my job at Lockheed Martin as an intern. Currently, I'm a manufacturing engineer supporting the fabrication operations of active production line. And last year, I was the manufacturing lead for IREC. So I'm happy you're all here, and move on to the next.
Hi guys, my name is Vera Fedor. I'm going to switch it up a little bit. I'm an electrical engineering major. And I am this year's director of mechatronic systems. So what does that mean? It means that I handle all of the electrical, computer science, computer engineering, and how it integrates with mechanical stuff. So I know KXR may seem like, oh, 90% aerostructures. Well, even though that's the case, even if you're computer science, electrical engineering, whatever, this is a great place to get hands-on experience. Just do a little plug for the EE people out there. Anyways, I like doing embedded electronics projects. I like working on interactive lighting projects, custom PCBs. I play bassoon. I love ASL, and just like Sam, I'm also a vegetarian.
So I'm Logan. I'm your director of propulsion. Go back. There you go. Alright, so I'm an aerospace major with a minor in computer science. I'm a CUF intern over at Lockheed. And some of my experience in KXR back in 2022, I was the assistant propulsion director for Firefighter 1025, where we got first place for that rocket. And last year, I was the engine lead on our Valkyrie, our first light rocket UCF in Florida as well. Yes. I mean, prop, we make the thing go up in the air, so excited to have you guys.
Alright, so these are our mascots. They have no power over you guys. Keep that in mind. They're just really wacky and zany. So, Samir, biggest Haas, and Tyler, please stand up.
Yeah, that's me!
You will come to love all of them. Alright, so.
What about Big Bird? Big Bird.
Is he here? Stand up! Alright, so we're going to go over our projects now. So we're going to go over operations in our workshop division. We're also going to go over SC Cup IREC, that's our hybrid engine. We're going to do fart sensor, liquid, ion pump, you can guess it's electric. Fastest student launch, solid development, solid. HPR program, and more of the projects we're planning in the future.
Jack, get up here. That's so loud. Okay, so we are operations and logistics. We kind of do all the important things that come for the overall arching of the club. Do you want to give a little introduction?
Hello. My name is Jack Billman. I'm your operations manager for this year. Not much to know about me.
I love you, Jack!
I love you too, random stranger. It's Jack! I love John. I didn't know it was you, John. I'm sorry. Yeah, I'm currently Lockheed Martin CUF. I'm in the quality engineering department. Before that, I was Human Factors Ergonomics engineering intern, and I joined KXR because my girlfriend likes rockets. I love my girlfriend, so that's why I'm here. Yeah, that's about it. Prepare for operations.
One little thing, if you guys are interested in merch, I've updated the store, and you guys can go on right now and order things. We're going to be handing this stuff out at the end of the GDM. It's all accurate. If something says it's out of stock, it's out of stock. Get your stuff down. Next slide, please. Okay, that's our introduction. You've met a couple of us. Yeah. Very hot. Okay. Oh, there it is again. So pins, flight tags, these shirts, all going to be out of stock. Get them now. Next slide. Okay. Sponsorships and funding. We use a lot of money. Like, rockets are expensive. This isn't cheap. We got to do something about it. Our e-board does a lot to facilitate that, but also we try and reach out to sponsors and get type of events going. One thing is we're going to announce some of the events that we're going to do at the very end, but tonight at Menchie's, that's a thing that's happening. I don't know if they can handle all of you, but we can try. And then we're going to be doing more stuff like that as well. And I'm going to let Jack.
Alrighty guys, outreach. Very, very important. I don't know how many of you here are extroverts or like talking about your club, something that's super passionate. I can tell this guy over here, very important. This guy over there, nice. But represent your club. Outreach is extremely important for our club. You guys are a voice for new people, tabling, going to different events like the Atlanta Science Center or what is
Frozen Aviation Day.
Yes, sorry. No Lockheed Martin Air Show. Lockheed Martin Air Show. It's a great place to network. Bottom line, outreach and volunteering is an extremely important part of our club. Yeah, you learn a lot doing it. I learned a lot doing it, and highly recommend. So, last slide for us, please. Yeah, logistics and media. So a lot of what we're going to do now in ops, this is going to be a new part of operations this year, is helping plan out a lot of what the logistics are going to be for the club. So a lot of the stuff you would normally think about, but this is very important stuff. Being able to get food for your members, being able to get housing, water, things of that nature. If you notice that map right up there, that's a location all the way to our competition this summer at FAR. So we have different options that we could pursue, but we need your help to find those kinds of options. You never know what's out there. It could be a van, could be a plane, could be a car, who knows. But we need to get there, and we need to bring our rockets there, and we need to compete, and we need to do well. And that's what logistics can do. Medium, I would say arguably one of the most important parts of our club. Outside of just taking cool photos and being able to help market the club, it's documentation. It's able to spread who we are to as many people as possible, as well as showcase our history to everybody. I don't know how many people here came just because of the Instagram post that we put out, but there is a lot that we do there, and I think it's extremely important. So if you guys want to come on by to operations, we'd love to have you. There's a lot you can do, and there's a lot we want you to do. So that's it.
Let's hear it for IRAC.
Good. Welcome everybody to the GDM to KXR, and we're the Spaceport America Cup IRAC team managers. I'm Gabriel Shamam. Next slide. I'm Gabriel Shamam. I'm a former Blue Origin intern this summer, and I'm your systems engineering and integration manager, and a founder of KXR, one of the founders.
Hi, I'm Sophie Riccio, the Aerostructures Manager. This is my third year in KXR. I started off as the assistant lead, or the lead of vehicle design on FAR. This past year, I was the integration lead of IRAC, and now I'm the manager.
Alright, hi everyone, I'm Keanu. I love space, as a lot of you might also. If you want to talk about space, come up to me anytime. I have a bunch of experience with, everything, robotics, computer programming, and now Rocketry. I've interned at Amazon and Canon Solutions America, and last year I joined this wonderful club, KXR. I was the experiments lead for NASA Student Launch, where I helped create the legendary pill. For those of you that know it, can we get a cheer? Woo! And for those of you that are new, if you want to make a payload that gets that loud cheer, you should join a payload system.
And I'm Samir. I came to this club last year as a freshman, and I saw like a chunk of graphite. I was like, wait, you can make rockets with pencil lead? Please sign me up. And so I joined the team. I became combustion lead. I worked with some amazing people to make the most amazing rocket I've ever seen, and I hope to do it again this year.
So behind me, you can see the large crowd in the picture. That's all the competition teams that come from over 158 countries or 158 colleges around the world. So we're talking about countries around the world, from Mexico, from Brazil, These teams come to Spaceport America where you guys can compete, trade, design and manufacturing knowledge, and basically showcase yourself to some of the biggest employers in aerospace as well. Blue Origin was their main sponsor last year, and Northrop Grumman, Relatively Space, are also, they participate in the convention that takes place there as well. It's in Las Cruces, New Mexico, so you get to see a wonderful view of the desert, I guess, the desert, right? So, yeah, this is the convention there. Next slide.
So who likes making fire? So I'm a bit biased, but I think propulsion is the best system out there. You get to make the rocket fuel, you get to make the flames, you get to break some concrete, and you get to make the whole thing go up in the air. So these are some pictures of my experience last year making the motor. There's a team right there in the corner. That was a great day. It was the first time we were able to fire the motor after like months of hard work. So this is a breakdown of the propulsion system. That's a diagram of last year's motor, and this year we're going to be making it twice as good, twice as powerful, to go 3 times as high, hopefully. So we're doing a hybrid motor. It has fundamentals of both solid propulsion and liquid propulsion, so I think it's one of the best propulsion types out there because you get a little bit of everything. You get to develop skills in all types of disciplines. That's a breakdown of subsystems. Each of them will have their own lead, and they'll be working together, so I hope to see all of you at my meetings.
All right, payload time. Who likes payloads? So I know there's a lot of aero majors around here, but if you are mechanical, if you are CS, if you are CE, electrical, this is the subsystem you want to be on. Maybe, I don't know, it's your choice. But if you think all these cool payloads here are interesting and you want to make something like that, that is what we're going to be doing. So next slide, please. So within IREC, there's something called the SDL Payload Challenge. Now, a really unique thing about this, there's other payload projects we do, but a lot of those other projects have different specific requirements, like you need to make a lander, a rover, this or that. IREC, there is virtually no requirements for what we have to do. We can make anything. So if you have a cool idea right now that you think that should be our payload, you should come to our meetings, you should propose it, because we will have a whole proposal solicitation process. You can learn more about that at our meetings, where we are going to choose the best payload idea. We're going to make it happen. I'm hoping to make UCF's coolest, most innovative payload in history. We're going. You want to make that? Come propose it. Yeah, there is a radioactive allowance, and it's not 0, surprisingly. We have 3 subsystems, mechanical, electrical, software. Those will all have leads, all work together closely. This is going to involve robotics. It's going to involve physics. If there's any physics majors in here, by a miracle, this would be really interesting. We can do physics experiments, even biology experiments. There's no way there's any bio majors in here, but if there is there anyone in here that's biology? No? All right. No, you're not. All right. Well, there's all of those things, and we're maybe even going to investigate doing a control system. That's not certain, but if you're interested in that, you should check it out. And I think that's everything.
All right, aerostructures. So these beautiful tubes you see over here is all aerostructures realm. If you like working with carbon fiber, with fiberglass, being in these fun little bunny suits over here, making rockets that are 14 feet tall, that's my realm. Next slide. So for IREC, we have 4 different subsystems. I broke it from the dynamics team, which is going to make sure that through a 30,000-foot flight, supersonic flight, we don't implode, zipper, blow up the rocket, destroy everything. We have our structures team, who's going to be designing the layup schedule, designing how the propulsion team interfaces in the rocket, how the payload interfaces, all of that fun stuff. Our recovery team will make sure we don't become a missile and get recruited by Lockheed. And then our manufacturing team who makes these amazing airframes. Some cool stuff we get to do on IREC is work with pre-preg and with researchers on campus called Dr. Go and work with an autoclave. So if you want to work with cool industry technology and make tubes, talk to me after GBM.
All right, so for the returning members this year, this might be a little bit new for you. So I am the Systems Engineering Integration Manager, and for my team here, we actually do something pretty special. We're currently trying to take KXR the highest and fastest it's ever gone, which means we need to have the best organization, the best engineering practice, and that's what our subsystem is for. We're basically the people who make sure that we make the right decision, the right designs, and we also take everything as safely and as correctly as possible. So behind me you can see a breakdown of our structure. We're part of the integration team, so there's that, and you will be overseeing the technical team, overseeing procedures and templates for all functions, and directing and monitoring tasks, basically industry standards for project management. It's going to be basically one of the most important roles on this team. Next slide. So before I bore you to death with more graphics, I promise you this is the last slide with them. Basically right here, we're going to be having 4 positions, 4 roles for leads on the team. It's going to be aerostructures integration, avionics, payloads, and propulsion GSC integration. And overall, you could work on any of those integration topics on the team as well. And basically, as you see right here, we're just making sure that the design process is going exactly how it should be. We're making sure we're making the right decisions every single time. Join if you want to make sure this project flows smoothly.
All right, I know we said a lot of information, and I know it sounds a little scary. I want to encourage you all to join no matter your skill level. Like I said, Samir came in as a freshman. I came to this team with no experience in engineering, nothing in rocketry, and now I'm a manager. At the end of the day, we are a family on IREC. A lot of the times we have to go out to Bar Louie after meetings or hang out. This was one of the memories I hold core after IREC. This is us taking Pegasus, our last IREC rocket, to inspection, and after a year of work, that feeling of bringing your time and effort to get judged is amazing. I want all of you to have that experience. And yeah, so please join.
So yeah, on the slide right now, you can see our meeting times. I apologize for there not being room numbers at the moment, but that will be announced in the Discord. If you haven't joined already, make sure to join. And we have our meetings weekly, and we make sure that we present to you all the information necessary, and we are moving towards the right direction in those meetings. So if you want to be contributing to design, to using industry level software, making sure this project is going the right way, come to the meetings. And our first one should be this upcoming Monday. We'll definitely pull out a poll and see if we want to move that, because I know it's a holiday then. But that being said, pay attention to hashtag IREC announcements and just the general announcements channel in the Discord, and also make sure to pay attention to the meeting schedule for updates. But yeah, here are the available lead spots on our project. So we will be eventually posting a lead application at some point in the first meeting, and here you could apply to lead roles that you would like to be basically taking up and be responsible for. So there's a lot of responsibility to go around in the project. It's meant for everybody of all experience levels. I want to emphasize that. It's a prestigious competition. It's in front of the most marketable big company audience in the world, but it's meant for you to start somewhere too in engineering. I highly encourage you to join. Thank you.
Hello everybody, there's a lot of you, which is so awesome to me. This is the biggest GBM I've definitely been to. I hope it is for you as well. But we are FAR 10K. Our first amateur rocketry 10K. Next slide please. Oh, okay, awesome. You want to take this guy? Okay.
Hey guys, so this is where things get really fun. This is the liquid bipropellant rocket engine, if you're not familiar with it. Right here, this big blue rocket, it's the pride and joy of KXR. We launched last year, and this was the first liquid bipropellant rocket launched by a university club in the state of Florida. Huge deal. And we brought a little video to share with you guys of our experience last year, so if you guys don't mind watching.
PD is disconnected.
We were really excited. much funding and a lot more time and preparedness to get this done. So next year it's going to be twice as big, twice as fast, and it's going to go twice as high.
Apologies for the technical difficulties. Oh no! How's everybody doing? Oh my goodness. Apologies about that. We're aerospace engineers, not IT majors. So, what is Friends of Amateur Rocketry 10K competition? We call it our 10K. It is an altitude and point-based competition. Points revolve around the altitude you reach and the payload you create. The focus is on the scientific payload, along with many other things. Something great about this competition is FAR is very, very open. They're not very strict on constraints, which is amazing for us as experimental rocketeers. You have the ability to create really amazing designs. And best of all, you can fly out with your friends, drive out with your friends, hang out at Airbnb, and then launch something you've been working for over a year on. So this project is going to be amazing. Like Kat said, last year was amazing. So I really want to invite you guys to join on us for this journey. Next slide. And one more thing about last year, I want to say congrats to everybody that was on the DPF team. Anybody that was on the DPF team, can you stand up? Anybody? Yeah. Have a round of applause, please. Not enough can be said about what a testament was last year. In less than 11 months, we became the first college in the state to launch a liquid rocket at a collegiate level. The prop team went from design to static fire in less than 11 months. And shout out to my aerostructures team, we went from no design to this 10-foot tall carbon fiber in less than 6 months. And this year we have twice the time and twice the budget. So this is us. We are the 4 managers for FAR 10K. I'm Tyler Marcial. I'm the aerostructure manager for this project. As you guess, my major is aerospace engineering.
Hi, my name is Xander, or as it's on there, Alexander. I'm the FAR Payloads manager for this year. I'm also aerospace, but I have a minor in computer science.
Hello, my name is Daniel Sherlock. I will be the systems engineering and integration manager. I'm a mechanical engineer. I've been building rockets since I was a freshman, led some teams, built more rockets, and helped found KXR.
Hi, my name is Catherine Daniel. I am this year's propulsions manager, and last year I was the system manager as well as the fluid systems lead for the propulsions team. So I'm looking forward to this project and what we can do with it this year. It's going to be really cool. All right, my slide. The propulsion system in the liquid bipropellant rocket is really what makes it stand out amongst the other rockets that we have here. It's a fully liquid bipropellant engine, like it says. You use a liquid fuel and a liquid oxidizer. This is the most common type of engine that you'll see being used in industry, and it's among the least common type of engine that you see on the collegiate level because they are really complex. But it doesn't mean that you can't do it, and it doesn't mean that you can't do it without experience. In fact, I really like having people on the team who come in with very little experience because we can all learn together. This is the CAD and some photos of last year's engine. Really, really neat project, and even if you're not particularly interested in propulsions, I encourage you to come and try it out because it's a really fun team. Next slide. So again, no experience is required, and this looks fantastic on a resume. If you're going to be working in the aerospace industry, I highly encourage you to get on this project because, like I said, it's very common in industry to have this type of engine. And then that's a video if you guys don't mind playing it. This is from our static fire last year. So we went out 6 times and tried to static fire this engine, and every single time we failed because, again, they're very complicated and we had so many problems last year. So when we finally got it to static fire, it was a huge deal, and hopefully this year we'll have quicker success. All right.
Hello, again, I'm the Fire Payloads Manager, and is anybody in here mechanical or electrical? Wow, yeah, there we go. Awesome, we need you guys. So basically, for this Payloads project, it's not as open as IREC, but there's a lot of constraints, which kind of makes it fun. We're going to be doing stuff with rovers, gliders, CubeSats, drones. We get to pick between all of those. And yeah, we're awarded points for it, so it's a pretty important part for our system. And I think the most important part of this is that it's fully student-led and developed, which leaves you guys to like research and to gain experience, which is what this club is all about.
All right, aerostructures, my turn. Aerostructures is the design, manufacturing, and optimization of all structures and components of the vehicle. It is my favorite part of the rocket. It's what I love about Rocketry. This year was the airframe from last year, which I was the manager for. Shout out to my aerostructures team again. They all did an amazing job. Yeah, and there's a couple pictures. But basically, as aerostructures, you're engineering the foundational design of the airframe. Something I want to make really clear is we've made 0 design choices this year because we're waiting for you and because we need your help. Part of this is developing as students and as engineers, and that's why our focus is on you. So I need your help designing an even bigger and cooler airframe this year. So if any of this interests you, please consider aerostructures. Next slide, please. Okay, big question to answer. Why are we the best sub-team or subsystem? I know, people might say we're not. I have one simple answer. Next slide, please. That's right, everybody. 7NC Loctite Breakout. Yeah! So for most of you, that joke probably went right over your head, and that's okay. Anybody on aerostructures from last year knows what this smells like, and hopefully doesn't know what this tastes like. But I promise you, if you join our team this year, you'll get to learn more about this amazing product. Next slide, please. Okay, what's actually great about aerostructures? It's you guys. It's you as members, and it's the team. And that's what I'm here for, is for you guys. I need your help. I want you guys on this project. As everybody said before, every single project requires no experience, okay? Last year I was in your seats as a freshman, and in the semester I became the manager for this airframe. Experience does not matter. It's the skill and your passion to cultivate a team. So I want to invite everybody to join us for an amazing journey again this year. And as you can see, there's a bunch of pictures. We goof off. We have a great time. Our culture is great. So join aerostructures, become an aero kid. That's amazing. Next thing. Last thing before they kick me off stage. So open lead positions. This year I'm going to have 6 subsystem leads. It's more than most projects, but I'm really excited and ambitious about this. The 6 of them are aerodynamic structures, nose cone, skin friction, aerodynamic components for rocket. I have flight dynamics. I really like the name of that one. Basically, their job is to make sure the rocket flies in the correct trajectory, it's stable, and everything's balanced. External structures, basically everything you see external to the rocket, all the carbon fiber, all the fiberglass, the thin material, really cool things, and aero fluids. And then for internal structures, often forgotten but very important, it's all the internal components, all the integration, propulsion, the airframe interfaces. A lot of work goes into the internal structures, especially with the complex system this year as a liquid propulsion system. Recovery, also very important. We want the rocket back in one piece. Recovery is a lot of fun. You see that explosion, that fireball. I think it's about 12 grams of black powder going off to deploy the parachutes. So recovery is a big, fun experience. They work with some energetic materials, and then manufacturing is really important. Can I have Matt, my manufacturing lead, stand up? Yeah, Matt, round of applause for us. I want to thank him for sacrificing his body for this airframe because he went through a lot of carbon. He did wear PPE though, so he's fine. But manufacturing is incredibly important. It makes sure the designs are manufacturable and able to be executed in time. Yeah, and again, these are all open. In a couple weeks, we'll post applications. But yeah, I encourage everybody to apply. This is a really amazing project. It's great for resumes, it's great for experience.
All right, hello. So if there's anything I've learned in rocketry over the years is that if anything can go wrong, it will. And that's why we have systems engineers. According to the International Council on Systems Engineering, we integrate all of the technical disciplines into a team, and we develop the structured development process that can take our team from concept to development to launching it on the stage. So as a systems engineer, our goal is to make sure that we are making the right engineering decisions, that we are making the right designs, and that our designs work the way that we intend to. So the structured engineering process that we're going to be applying to our project, which is mimicking industry, is lots of requirements, trade studies, con-ops, interface control documents, risk management, verification cross-reference matrices, checklists, and launch procedures. Next slide, please. So there's a lot of reasons to join the systems engineering team. Of course, we are the developmental process. We are not making the content, but we are ensuring it is being done properly and on schedule. So if you like money, systems engineers get paid $8,000 to $9,000 more than entry-level aerospace and mechanical engineers. That's why I joined it. You can also get a very broad view, a holistic view of our systems. You get to see a little bit of everything, whereas a lot of the other engineers have a very specific niche. Also, we balance a lot of project management criteria like cost, schedule, performance, and interaction between the systems. And if you have a lot of excellent verbal and communication skills, this is a great way where you can be an engineer and use those communication skills. So as our systems engineering team, you'll be specializing in one of the 3 technical systems, and then you'll be facilitating the whole engineering development process. We'll also be doing media leads and safety leads too. Thank you very much. Last slide. So one more. Our kickoff meeting is going to be this Monday at 7:30 p.m. This is an integration meeting that's going to be happening bi-weekly where we integrate all of our teams together. And this is also going to start the kickoff of the rest of our system meetings. So we hope to see you there. This project is really fascinating, one of the most complicated and interesting propulsion systems that exists right now. Also, have you guys heard of that club, Says UCF? I guess not. So we get to go to California with them and compete against clubs like Says UCF. So this is a really fun opportunity where we get to compete against friendly peers like that. So we really hope that you guys can join us and be part of that. Thank you.
I'm an aerospace engineering major, been in KXR for about the past 3 years now, and I am the manager for the 2nd year of ion propulsion at KXR. For those that are wondering, ion propulsion, it's pretty different from the other projects. We don't go to a competition. It's really just a propulsion system. It's not a whole vehicle. It's more research development oriented, and our goal is to develop and test an electric propulsion thruster. Electric propulsion is basically the kind of propulsion you see on satellites and spacecraft. It works in a vacuum, and instead of using chemicals to power it like you would see in your liquid engine or in your hybrid engine, we use electricity. Essentially, this technology, it's low thrust, super efficient, which is why you want to use it. So last year, Zeus, which was the name of our thruster that we designed, you can see it right here at the front of the room, We were successfully fired this at the Florida Space Institute vacuum chamber. It was actually 3 weeks ago when we had our test. So you can see the photos down there. That's close-ups of Zeus. You can see it in the vacuum chamber testing. And I'd actually, right now, like to recognize the team last year for their incredible work in pulling off this achievement. So please, can we give them all a round of applause? Electric propulsion is very uncommon, especially at the undergraduate level. There are no other university teams in the entire state of Florida that have even attempted something like this. And there are less than a dozen universities in the whole nation that have done something like this. Not only that, we're an RSO, we're affiliated but not sponsored by UCF, which means we're actually the only non-sponsored team from an undergraduate level to do an electric thruster. So if you're interested in space technology, you want to do something really unique, this is a really, really good project to put on your resume. It's very rare and it's very, very cool. And it's also used in industry. This is real technology that we work on. So Zeus, that was a radio frequency powered gridded ion thruster. If you know what that means, don't worry about it. That's just the type of thruster it was. And it was fueled by argon, which is why it glows purple. But we're not doing that this year. This year, we're going to actually be doing a new thruster type. This is called a Hall effect thruster. This is used much more extensively in industry. These actually power the Starlink satellites that SpaceX launches every week or so. This also powers, or is supposed to power NASA's proposed Gateway, which is their space station that's going to be in the moon or near something like that. But really, really cool. These are used much more common than the gridded thruster that we made. They can actually produce more thrust than those gridded thrusters, but the key difference is that they don't have grids. They use magnets. So if you like magnets, another fun project to join. So go to the next slide. The breakdown for Hall effect, we're going to have two teams. The first is the electrical team. This is the team that's going to be in charge of the electromagnet design, the power electronics design, testing, all those components and such. If you guys are really interested in electrical engineering, how many just electrical engineers do we have in this room? Oh, awesome. Come to my project. I want you guys on my project. This is a really, really cool project to be, especially, again, if you're into space, because this is powered by electricity. So we really, really want electrical engineers on this team. But if you're not and you still want to learn about how to power these kinds of thrusters, join this team, because you can work with electromagnets. You're going to have to work with a lot of power supplies, power electronics. You're going to learn about power processing. And these are topics that you don't even learn in undergraduate level electrical engineering. They're very high-level topics that are brought to you guys. You guys get to work on this. You get to learn this. And don't let that intimidate you. You should be excited to get to work on something so unique at your level. The next team is the mechanical team. This, of course, is not focused on the power of the thruster, but the thruster itself. So this will be the physical thruster design, in addition to the propellant fluid system that feeds gas to the thruster and allows it to move. So it's not going to move, it's just tested. But this will be focused on the channel design, which is that little annulus ring you see there, the electrodes, which is just a fancy word for saying the inlet and the exit, and then, of course, I already mentioned the fluid systems. So if you're interested in unique material science, this is a really cool project. We have a lot of tough material challenges that we have to overcome. If you guys are into that kind of thing, this is a really cool design to get involved on. And of course, mechanical design, you get to design a space thruster. Who doesn't want to do that, right? So a lot of really, really cool things to get involved with. Yeah, we also have a systems integration team. Gabe and Jenny already talked about it, so I'm not going to bore you guys with that stuff anymore. But it is a really important system too. We have a pretty complex project here. This isn't, even though it's just a propulsion system, it's not to be, thought of as simple as the other propulsion systems here. It's very unique, very new. This is only our second year of it, and we're doing another different type of thruster. So being able to have people in charge of making sure we can integrate, work with each other, we have problems being solved across the different systems is incredibly important. So if you want to be involved in this project and you like this, but you don't know what you want to do, or you feel like you're not really into electrical or materials or anything, you could get on this team, you could get an overarching view of how the project works, and you can still help us work towards a successful fire of UCF's next electric thruster. So a lot of people have actually come up to me about this project already, which I love, by the way. I'm really glad you guys are really interested in this. So if you want to join, everyone keeps asking me, how do I join? How do I get involved? Super easy. Just come to the meetings. But step one, get on a Discord and make sure you select the ion propulsion role. That's how I know you're the coolest person in the room, and how you can see the announcements channel for ION, where you can see where the room's going to be, what time the meetings are going to be, and you can also learn about the system meetings once they're decided, which will be after our first meeting. So this next Thursday at 6 p.m. we're going to be meeting. I'll be going more in depth about the Hall effect thruster design and how the project structure is going to look, what the different teams are going to be, and you can learn more about specifically how you can get involved. I'll talk more about the systems role as well. So get involved, join the Discord, get the role, come to the first meeting, and absolutely no experience is necessary. We started last year with zero knowledge about this kind of thruster, and we did it in less than a year. We did it successfully, and we joined an elite group of universities in the nation that have done this. So don't be intimidated. Come on, learn with us. It's going to be a lot of fun. And the last slide here are the open positions we have. I'll go more into depth on the lead positions next Thursday, but I have two positions I want to announce tonight. We have the electrical manager and the mechanical manager. I actually had to ask eBoard today if I could have more managers on my project. I don't think there's any other manager positions. So if you're really interested in doing project management, which is the same role that I'm doing, but for, of course, for the systems on this project, then these are possible roles you should check out. And the forms for those will come out next week, and I'll go more in depth on them at our meeting next Thursday. But those are currently the open positions. And like I said, we'll go over the lead meetings, or the lead positions at our meetings next week. Thank you.
Hello. Hey everybody, my name is Stan Root. I am the Systems Engineering and Integration Manager for this year's NASA student launch. I'm also an aerospace engineer. This is my sophomore year here. I joined KXR spring, so last semester, and got to work on the telemetry team for NASA student launch. So I got to have a real nice introduction to Rocketry, and now I got to be manager for this amazing project.
I'm Nicholas Rizik. I am the Payload manager for NSL. I'm a sophomore mechanical engineering major. I joined NSL last semester around December-ish, part of the experiments team for NSL.
So here's a little bit about NSL. I'm sure you've heard Amelia talk about it at the beginning of the presentation. But this is our Artemis Student Challenge here. So this is like directly with NASA, which is why it's called NASA Student Launch. But last year we placed third, and we launch every year in Huntsville, and hopefully make it to tour their NASA site this year. Great first experience in a rocketry. Everybody would say it really doesn't matter your major. This is a great experience, especially for freshmen. I'm sure, actually, most people last year's project, I'm pretty sure, were also freshmen. And you get to gain connections, experience on everything from aerostructures to payloads and systems integration.
So this year we were given our payload challenge. We are to design an atmospheric independent lander to safely retain and recover a group of 4 STEM mods. Essentially, also, we can't use a parachute or anything, so we kind of have to simulate the landing on a moon, except from 400 to 800 feet on our way down from launching this rocket. We're essentially just going to use little Lego people for our little astronauts. Kit them out in KXR merch, you know what it is. So yeah, the challenge is basically representing the design process that NASA engineers themselves have to go through, just on a little bit smaller of a scale. It will be difficult, but it is beginner friendly. I'm very excited for it. It seems like an awesome project to have.
So our aerostructures manager couldn't be here, unfortunately, but aerostructures is going to be really great this year. You get to design, simulate, test, and launch the rocket according to all the guidelines set by NASA. We're doing a subscale and a full-scale rocket as required for the competition. We're going for around 4,000 feet at apogee, which is the highest point a rocket achieves. And you'll you'll gain some serious skills. I'm pretty sure you've heard earlier people talking about working with fiberglass and carbon fiber to build both these amazing rocket bodies. The softwares that you'll get experience in, definitely OnShape and OpenRocket. The materials, like I mentioned earlier, working with carbon fiber and fiberglass, and this year we're using a class motor, I believe, and maybe an L. So our first meeting is September 5th, which is next Tuesday at 7 p.m. The room is yet to be decided. And here's the list of our other meeting times. So we have Payloads Monday, Aerostructures Tuesday, and Integration on Thursday. We'll also be announcing lead positions after our first meeting or so. So definitely look out for that. Join the NASA section of the Discord to see all announcements and all the other chats. All right. Thank you so much, and hopefully we get to see many of you soon.
Hi everybody, my name is Nate. I am a third-year aerospace engineer. Surprise, surprise. I am the solid development manager. You can go on to the next slide. So before this project, we had the solid prop project. Shout out Jonathan Perez. You can stand up if you want. He was the past manager of that project. So we were able to build two L-class motors, each with about a peak thrust of maybe 300 pounds, a little bit more. We use off-the-shelf grains, off-the-shelf propellant. So what are we doing now? We're going to be putting the E in KXR. We are developing our very own propellant, APCP, ammonium chlorate composite propellant, something that UCF has never done before. It's a pretty complex and fun process, but we haven't decided anything yet. So this project is completely bare bones. There is so much room for innovation. We are also going to be improving our motor casings. So far we've only built aluminum motor casings, and so we're going to try and build carbon fiber reinforced ones, which is also something that's pretty complex. So there's a lot of stuff to do. There's a lot of words here. I'm not going to read through all of them. You can take a picture. There is a propellant development team, a pressure vessel development team, a testing and safety team. So if you want to get involved, you can get involved on any of these teams. There's a lot of stuff to do, a lot of cool, fun propulsion stuff. You can make things go boom. So the meeting time is Tuesday at 6 p.m. There are 4 lead positions open. It's propellant development lead, pressure vessel development lead, testing lead, and safety lead. And make sure you pick the solid development role in Discord to receive updates. Not solid motor project. That one's not active anymore. Don't pick that one. Yeah, so engineering 1, room 435. Make sure to come.
Hello. Alright, so LTI, my name is Andres. I'm one of the managers, specifically the computer systems for ground support.
And I'm Emilio Armas. I'm not the president, I'm the avionics manager. Zach, our structures manager, could not be here tonight, unfortunately, but let's go ahead and start.
Alright, so what's LTI? So Launch Test Infrastructure. So who wants to see the fire? Who wants to see the static fire? Who wants to see the launch? Well, guess what? Everything LTI. So LTI is basically all the infrastructure to test and launch our engines. So we do the static fires, the go flows, you name it. We also deal with the rail. So everything's cool here. We divide LTI into 2 subsystems. We have ground support and avionics. So ground support, everything ground related, all the equipment that we use to launch, and then avionics, Emil's gonna talk about it later, but all the sensors in the rocket. Next slide. So ground support systems, we divide into 2 systems, mechanical and computing. Zach is not here, but he's in charge of the mechanical, and you can see a lot of pictures. We do a lot. So you see all the mechanisms that we use to pressurize the tank, fuel the engine, and also ignite. I love that picture over there, us running simulations on our test tent, basically to check if we can handle the forces of the engine. It's a really useful skill used in the industry. So if you want to learn, please join LTI. Next slide. Now, computing system, that's my thing. So raise your hand if you're a computer engineer, computer science, raise your hand. Well, guess what? This is the place for you. So computer science, we deal a lot. Essentially, data gathering for all the tests, data acquisition, propulsion control, control interface. You can see all of our pictures. Right here we have our interface system. We built the big red button to launch. So if you want to join us, please. Next slide. All right, avionics.
Ooh, this is not, okay, cool. Yeah, avionics is everything that goes in the rocket. All the electronics that go into the rocket that start going up and hopefully come back down in one piece. So our system that I'm going to be, I'm really excited to manage this year. We're going to be designing a lot of embedded systems for computing, data acquisition. We're going to be doing really dense PCBs, doing all the telemetry. And the idea is we're going to be creating what's called a universal flight computer for all of KXR. So this flight computer will be in charge, and it's going to be able to have an embedded operating system on it. If any of you guys know what a real-time operating system is, join my system. We're going to be hosting all of the programs, all of like the C, C++, all the routines for everything that needs to happen on the rocket. And we're going to be working very closely with every payload team that's going to be here in KXR this year. We also are going to be in charge of the propulsion control board. We picked a little funny name. We're calling it the PCB squared because it will also be a PCB. This PCB will be in charge of the valve actuation. It's going to be in charge of getting all of the sensor data across all of our propulsion systems, and it's also going to be in that universal family of being able to be adapted to every single control and propulsion system that we need. So on the pictures, the vibe, the static fires are great. If you're going to be on LTI, this is going to be your team. And if you're eating a sandwich, here is the avionics from last year. The Valkyrie flight computer from the FAR DPF team, that's the purple one. And Vera, big shout out, designing the Pegasus nose cone and the power distribution board. Ethan, if you're also here, thank you for coming. He also designed the avionics board. Very nice. Woo! Next slide. All right, our meetings are a little bit lackluster right now because the only thing we have is integration meetings. Our system covers such a wide range that we're going to have such a large amount of leads. We're going to be doing our kickoff meeting next Thursday at 7 p.m. Room TBD. We're going to figure that one out pretty soon. And we have a lot of leads. So we have our electrical, main electrical lead. We have a mechanism structures, those two more mechanical. And then we have 3 software leads. If you want to do any software, any CS majors, whether you're working on an operating system or whether you're working on bare metal code, if you know anything about all of that, join one of those 3 teams. We're going to also be looking to get embedded design, which is going to be in charge of things like microcontrollers and FPGAs. If you know what an FPGA is also, please join my team. And RF telemetry. There's also a special lead role that's going to be in this year for operations and logistics. This is going to be a very interesting lead role that's going to be in charge of kind of handling all of LTI and being kind of like the SCI that you've been hearing about in all the other presentations for our system. So again, all the specific meetings for our subsystems will be determined pretty soon, and just come to our kickoff meeting. Thank you.
I also want to say that if you have no idea what project to join, I highly suggest LTI because it's a mix of everything. Not only you get to work with all the other projects, all the other different propulsion systems, but you also learn different other things. We do mechanisms, controls, interface, telemetry, electrical, all majors, even civil engineers. We need you. So please join us.
If you want to press the big red button, this is the team to join. Hello?
Alright. Hey guys, I'm the high-powered Rocketry manager here at KXR. My name is Jake Goldberg. I'm a mechanical engineering senior.
I work at Siemens Energy. I do combustion research with like alternate fuels. So next slide. So just to recap the 2022 to 2023 school year, we had over 70 L1 certifications. So that's quite a bit. That's like most of the clubs before this point. We had 5 L2 certifications. We did UCS Camp Connect program, which basically is a program UCF hosts that high schools and middle schools can come in and do a lot of like various engineering related activities. And we started doing our L2 program testing. So what is high-powered rocketry? So all these rockets you see here today, right? They all have something to do with high-powered rocketry. This is more on the amateur side of rocketry, but every single one you need to have someone that has a certification to be able to fly it. So that's what we take care of. There's 3 different levels. You have level 1, which basically is these small rockets here, and KXR offers a program that you can go in and design your rocket, launch it in Palm Bay, so you get your certification. Great way to learn about rocketry. Everything from aerostructures, simple recovery, simple designs of motors, how to ignite them, etc. How high they go, all different types of things. So this is why HPR is important. And the things that basically go through the different levels is the higher level, basically, the higher the motor you can get. And then every single KXR project, like I mentioned, needs somebody that has that certification to be able to launch. For instance, NASA student launched last year. They used the K1000. Yeah, and so that's a level 2 level rocket motor. So you needed someone there that basically had the L2 experience, which was our launch lead, Nathan S., to actually be able to launch it. So this is something very important to the club, and it's a really great way to get introduced to rocketry. Next slide. So L1 certs. All right, for raise a hand, who has their L1 cert? Woo! All right, so that means everyone else that hasn't raised their hand should be in the L1 program. I'll be expecting you. So in a few months, actually, because we have to postpone it to the latter end of the semester due to some unforeseen circumstances. But we're going to come back stronger, and we're going to get our own dedicated launch system so that we don't have to wait in line or wait in the sun all day. We can just go out there and launch as many people as possible, basically. From now on, we're going to be limiting it to about 50 people a semester. Before, we were doing over 100, and it's just unsustainable, and the launch day just takes forever. So, like I said earlier, for the L1 certification, the whole point is to design, manufacture, and launch your own rocket. So, instead of having like an entire team work on this rocket, you can just build your own rocket, get your certification, and then basically put yourself through every single stage of how a rocket functions. And then you get to actually launch a rocket, which is the coolest part. So you guys, anybody here that's gotten their L1 certification, it's very quick and it's a very fun project to do. So next one. And then I'm glad to introduce the L2 certification program led by Kenneth right here. So this program has been in the works since the beginning of the year, actually, and we're just getting to the point where we're finishing up, creating all the documentation, going through the moves so we can make sure that this program runs smoothly. The initial trial period is going to be limited to 5 people, which I know isn't a lot, but this is a very in-depth program. The L1 program, traditionally how it functioned is you go on to our web courses, you make a little, we have tutorials and whatnot, you make your own rocket, submit the design, and come and build it. For an L2, you're going to have to prove that you know what you're doing, basically. We're going to be there to help you, but you're going to be designing the entire recovery system, all the electronics, you're going to work on the aerostructures portion of it, the recovery portion of it, and the motor portion of it. So it's basically one of our project rockets, but kind of small scale. So you get your hands on every single part of the rocket again. This is also a great way to get into the more complex rockets because you put your hands on every single thing, and then you can go into the projects and go to recovery or go to propulsion or whatever interests you guys the most. And so I'm also proud and very excited to introduce Nightworks. It's kind of a play on Skunk Works from Lockheed, but the lead here, Jonathan Perez. Yeah. Woo! Woo! Yeah. So the point of Nightworks is basically doing everything experimental that the projects don't have time to do. So, for example, air brakes, right? Air brakes are super cool. Everyone wants to do them, but some of our projects don't have the time or funding to be able to do this in the time period allowed. A lot of this stuff takes a lot of time and effort, and they're fairly complex. So it's something that KXR is interested in developing, but does not want to put on a project. There's going to be a lot involved with these. We're going to do everything from coding, mechanical design, manufacturing, basically anything that you could do with a rocket or any like mechanism. We're going to work with. That's crazy. So we're going to be working with other KXR projects to spearhead this. So if a project has an idea or a design that they don't necessarily want to integrate initially, they're going to basically come to Nightworks and we're kind of just build it and test it. And the main point of this program is like R&D. So this is kind of it's very experimental what we're doing. So we're going to go through and basically develop these things for the projects to have access to documents and resources in the future so that they can implement these systems way faster than developing them by themselves. And like I said, some of the program, what we have on the list right now is we're going to be doing dynamic air brakes so we can hit precise altitude for competitions, because in a lot of competitions you have to hit a certain altitude to get points. So then we're going to do CO2 ejection, which is more reliable and more efficient at higher altitudes compared to black powder due to like the pressure differences and whatnot. And then basically anything that's cool or useful or something we want to look into. I mean, it could be anything really. So that's what Nightworks is. I'm very excited to announce that. The first meeting is probably going to be next week. We're still dialing in the details, but I'll for sure put out an announcement about it. So yeah, that's it.
If you guys haven't scanned this QR code, scan it right now. You are going to need it for this section. All right, anyone still need the QR code? Scanning, everyone good? I'll wait. All right, there we go. All right, so membership form. This is the first step of getting started. This does not make you a dues-paying member, but every member does have to fill out this form. It's pretty quick. It just asks you for basic information. Your personal information is never sold. We take everything as anonymous names and we share that with sponsors to give you guys project money. So again, if you don't want to answer any questions, so you can always put prefer not to answer. So this is a quick form. Definitely do it after the GDM if you can't do it now. Next slide. Follow our socials. We post a lot of stuff on our Instagram. Our Night Connect lets you get news about us. We also have a purchases community on the website, so you guys want cool little photos, you guys want flight tags, you guys want voters as well for the HPR workshop, it's all on our website. Discord, that's the main thing. If it's not on Discord, it's not real. If you tell me something and it wasn't on Discord, I never heard you. So yes, get on Discord, that's where you do all our software access, we pay dues, that's where all the leadership and manager applications come out. And honestly, a lot of the development, a lot of the resources are posted in Discord too. So again, if it's not on Discord, it's not real. So real quick, who here does not have Discord downloaded? Raise your hand. Bad! I see you in the back, bad! Download it! Because they don't have Discord. Sorry, I'm trying to make an example out of you. I only saw your hand. Next slide.
Alright, pay your dues! Copy, get out here. Real quick. She's a treasurer, she's a tax collector.
Pay your dues, I'm gonna pull a knife on you.
Pay your dues! Dues are cheap. 25 per year, 15 for 6 months. Dues are cheap. Gotta be threatening some. No, but in all seriousness, you can't do anything in the club without dues. You can't apply for lead positions. You'll be automatically voided if you do not pay your dues. I can track all of it now. I am a big brother. But, you know, it lets you $10 workshops, $10 projects as well. It gets you access to hiring events. I will not send your resume if you guys are not dues-paying members. I've had the issue before for the Lockheed program. We had people who didn't want to pay dues. I withheld those resumes. So, yeah, I'm being fully loaned you. I will not send your resume if you don't pay your dues. It's unfair to the people who do. This also, again, lets you go on other tours as well. We have a Kennedy Space Center tour coming up, as well as a Blue Origin one soon. Yeah, this is on the website, or on Discord too. Sorry, Discord, not website, I'm a liar. You see those two little links, that's all you press. This is through Launchpad, one of our sponsors. They will not sell any of your information either. Next slide. SharePoint. If you guys know what Microsoft SharePoint is, it's a great tool. So you can join our Microsoft team, and that'll give you access to our SharePoint that has all our information. So if you guys want all our research on how we build a rocket, all our CAD, it's all in the SharePoint for any UCF students to use. Just make sure to pay your dues, you have full access to it, and you guys get a lot of opportunities with that. Discord rules, again, it's pretty simple. So this is the main thing. I'm kind of sick of having to DM everyone to do this. I feel like an asshole. Just change your name to first name, last name, and then put your project. If you don't know what project you want to do, just leave it blank. But yeah, make sure we want to know who you are. We want to put a name to those pretty faces, so just put first name, last name. Then check out meeting schedules. That is being updated by Sam as we speak. Agree to our terms, then choose your roles and hashtag roles if you didn't win it. Upcoming events. Actually, real quick, I know someone will say a few words, so I'm gonna give the mic off to him.
So, hi guys. You know, I wanted to make an announcement about safety and kind of club culture. You know, at the end of the day, we're all Rocketeers. We work with materials that are not very commonly presented in front of you. So regardless of what you see on these presentations, you know, we all know how to have a fun time doing rocketry, but we are all trained and we all do very safe practices at the end of the day. We handle these materials with care. We handle all of our fuels with care, especially composites. Composites are relatively dangerous. You shouldn't handle them if you don't know what you're doing. But what we provide here is an opportunity to teach you guys how to handle these materials. You know, in industry, you're not really given this opportunity. You know, I work as a manufacturing engineer at Lockheed Martin. I see items on my desk every day. I don't do with those items what I do here. You know, it's an entirely new experience what you get from this club. But I urge you guys to be safe in your practices. Take everything that you see with a grain of salt. Additionally, club culture. You know, we've had some issues in our past. But moving forward, I want to urge all of you guys, if you have any issues with individuals or things that you want to see improved in the club, you know, us as an e-board, we are here to represent your opinions. So please feel free to come to any of us, message us on Discord anytime with any concerns or comments that you have. Okay? I hope to see you all very soon in these projects, and best of luck.
Thank you. So, yeah, I mean, for reference, carbon fiber and the materials we work with are cancers. There is due process that needs to be taken. So we have the keyboard and the directors, as well as the project managers and safety leads, making sure it's done properly. But yeah, we definitely want to make sure everything's done correctly. So very well put by Sam. But I guess next slide. It's the big one. The Blue Origin hiring event. So Blue Origin is looking for a lot of people, actually looking for full-time and internships. But this will be September 26th, 7 p.m. in Room TBA. They're looking for anything from CS to electrical engineering to aerospace. They want all of you guys. You must be a dues-paying member to attend. You can show up for the workshop if you like, if you're not going to get your resume through. Okay, you get to network with Blue Origin engineers. They'll be doing a presentation. They'll be talking about the process for signing up, and then they'll also be able to just talk to them, give them your resume, have them critique it. Next slide, please. JVC hiring event. This is another company that wants to hire directly from JXR. So Dave and Time is current TBA, but it's a huge opportunity for people interested in planes and also ground support equipment. So especially people in LTI will be interested in this. But they do a lot of cool stuff. They also do refrigerants, that's something they're interested in. But yeah, we are also hoping to tour the facility as well. Astronautics tour. That is your turn.
Can I get a huge thank you to Jack and Andres, and it was Zach Maynard who was there as well, right? Okay. This is a research facility that's right out on Research Park, right? I don't think they're research, I think they're just a company. They're just a company. But they're mostly for compies, CS, EE. They're more on that type of side. They do sort of what launch test infrastructure does. They do test systems. They want us to come forward. We're going to have another collaboration with them. And if you're in that kind of scope, and even if you're a Mackie, they hire Mackies as well. Come and check this out. We're going to be announcing more about this.
Next slide. ABL Space Systems. So these are a startup. This is a startup out in California. They've been around for a couple of years now. They do really interesting stuff. They actually, again, want to recruit directly from KXR. They're looking for interns and full-time, but the main thing is they want to actually do informal presentations. So we're gonna present to them actually. So when you guys start off your project, you guys will present to them October 11th, and then they're gonna present back to us, and then it's just gonna be an hour of you speaking with their engineers, and they want to recruit just pretty much, if they like you, they'll recruit you. They're really looking for new people, and they really like the work we've done in the past. Lockheed Martin Space and Air Show. So this is actually a really fun event. There's as many people you guys want to sign up. Honestly, you get to be a dues paying member, but there's a bunch of slots. So you guys will essentially work and serve at the event, but you guys will also get to tour and speak with Lockheed officials, as well as officials from other companies. You won't be working the entire 8 hours, don't worry. Yeah, generally it's just a really good time. A lot of people win the pass and they love it, so I definitely recommend going out if you want to go to pass it.
So another opportunity we have for you guys is a composites workshop. With the help of Dylan Desoy and a couple other members, we were able to get an actual Lockheed Martin employee who directly works with internal research and development composites to come and give us some composites lessons. So those are going to happen every Friday in October from 11 to 1 p.m. We'll be sending out some information and some interest forms for that, and I hope to see you there as well.
So you guys might look around and be like, hey, there's a lot of women for engineering in this room, but it's still mostly dudes. So I'd like to propose that you guys come help us out at Girls in Aviation Day in Tampa. We're going to get a little group together to go out, and we're going to table, and it's going to be a bunch of girls who are interested in aviation and encouraging them to continue on that path. There's going to be a keynote speaker. It was after the Taliban had been disbanded. She was the first female pilot, and I forget which country, but it's going to be really cool. We went last year, and it was a good time. So if you like encouraging that type of stuff, come in. There's a channel in the Discord about it.
This is the other thing. So we have a Menchie's after party. So Menchie's is prepared for up to 400 people right now. So I don't think we're gonna have all 400 go, but if you wanted to, you could. But yeah, the Menchie's on Plaza. It's the closest Menchie's here. They're ready with open arms to accept us. So yeah, after the TPM, after everyone gets to ask their questions, we're gonna go ahead and rate them. Hopefully it'll be a good time. Yeah.
Merch.
Hello. So, if you were interested in buying our merch, which you have the availability to look at on the website, or if you want to see it in person, we have a table down there so that after this meeting ends, which is going to be soon, we want you guys to kind of make a line and then come through. So, Jack can also get to you, which he has provided.
Hey guys, I got Monster for y'all. If any of you are interested in getting Monster, just know there are currently 216 cans with a variety of different flavors brought to you. That's what I was gonna say. So first come, first serve. Only thing I gotta do is, since it's supplied by Monster, I gotta take a picture. You know, make it diverse, make it cool. Monster. You know. Yeah, that's about it.
Yep. Do not start storming the table for Monster, please. Okay, so upcoming merch. What are the other cool? Yeah. So one of the other things about KXR is that we're actually not just an RSO. Hey guys, settle down please. Thank you. Yeah, so one of the cool things about KXR is that we're not just an RSO, we're also a 501c3 Type 2 nonprofit corporation. What that means for us is that we get to be a community of our partners, or our partner community. Whatever, regardless though. So one of the things we're doing right now is we're going to do a cancer event for breast cancer awareness in October. So we won't be able to go to the Lake Yola Walk due to the time conflict with the Lockheed Martin Air Show, and we decided to make these cancer awareness shirts our actual uniform for the air show. Obviously you don't have to buy them, but we would encourage you, especially if you want to go to the air show. But the other thing is all the proceeds will go to Relay for Life, which goes to the American Cancer Society. None of these profits will be going to KXR themselves. We're also, Bucket Hats won the Super Bowl, so they actually sadly beat up the PJ Pants, my personal favorite. But Bucket Hats will be released soon. Next slide. Thank you. Yeah. Guys, this is ridiculous. We are the biggest RSO on campus. Now, feel free, please, nice and calmly, go get some Monster. You can eat all animals, all of you. Real quick.
Okay, before you move, I see all of you moving, stay in your place, okay? Simon says, sit, stand, stay, okay? If you bought merch, please go to the table. We can't take cash and like a direct transaction. You can buy it online through the website and just tell me your name. I can give you your merch and I can fulfill it, and then you can walk down the line. If you're not buying merch, just keep going. Thank you.
Hey, in addition, if you guys have any questions,